two-dimensional vectors. Remember we mentioned that vectors move in directions. So these two dimensions telling us that we have a y-axis This two dimension is indicating that we have a y-axis and an x-axis. The y, like I initially mentioned, the y-axis is a north, and the x-axis is the y-axis could be the north and the south, and the x-axis would be the east and the west. But now, in terms of vector, we denote the x and the y with its I and j. So when you say this part is always denoted with the I, and this part is denoted with the j. And that's how it's been defined for two-dimensional vectors, because the vectors have two dimensions. You can have here and here. So let's assume this I is 3. Let's assume this is 3j and this is 4I. So that's the dimension. Now, once you just hear 3j, you know it's on the north. But if you hear 3-3j, you know it's on the south part. 4I is on the east, then negative 4I is on the western side. So that's how it defines that dimensions. Okay. And now we have, like what I mentioned before, when we're talking about the two-dimensional vectors, for instance, when a vector of A, these are the whole vector. This is the A part of the vector. Since if the B is on the I-axis, is equals to 3I, and the C is equals to 4j. So for us to find the sum of the A and the B, we'll have to add this up, like we discussed before, since they are both in the positive direction. So it's just be 3I plus 4j. It can never be 3I plus 4j is equals to 7. This is just going to be the response, 3I plus 4j, and not this. Because this one's telling us is 3I, that is on the x-axis, and 4j on the y-axis. So just the coordinates of the locations or the coordinates on the dimensional vectors. That's how that is being defined. Hope that explains it better for you. Remember, the x-axis is the I, the y-axis is the j. And let's move on to the other ones. We have talked about the vectors operation using components. When we are talking about components makes the vector operations of addition, subtraction, and scalar quantities, scalar multiplications easy. If you remember what we talked about before in terms of vector calculations and scalar calculations, now we're talking about components of both the vector calculations. Now looking at the vector calculations, when we have a vector of A and B, we have A and B. First calculate the A and B. We look at have this drawings out. First calculate this A and B. We have AX, BX, because we have A here, no. Then we have A here, we have A. On this, we have B, we have A2 here, and we have B. But B anywhere here. So when we say A on the x-axis, this is the A on the x-axis plus sorry about that. This is the addition. You have the AX plus BX, I, then the AY plus BY, J. So what that is saying is, on the x-axis, the A and the B on the x-axis, then the A and the B on the y-axis. This is what this is saying, the A and the B on each of those axes. Then you add them up together. Let's assume the A is here, and here is B, then here is A, and here is A, and here is B. So when you want to add it up, you just say AX plus BXI, then AY plus BYI. That is for the addition.